In this research, we present a gaze gesture-based user authentication system to counter shoulder surfing attacks. The system consists of a set of 36 shapes on the screen, and the user interfaces through an eye-tracking device. These shapes move simultaneously on the screen, each shape following a unique path. The system recognizes which path the user is following using eye-tracking data to perform authentication. The user sets a password by selecting 3 shapes from the password selection interface, one for each of the 3 frames. Here the user has selected the square, star, and pi shapes. The user controls the interface through a set of hotkeys. A is pressed to initiate the shape's transition on a frame. Z is pressed to cancel the last recorded frame in case the user blinks, sneezes, or for any other error recovery. M is pressed to submit the password after recording 3 frames. Lastly, P is pressed to select a password from the password selection window. Now we will see the user attempt to authenticate using her shaped password. She will first follow the square. The user's scan path is shown here as a visual aid, but the user does not see this feedback during authentication. Next, she will follow the star. Finally, she will follow the pi shape to authenticate. The system will detect which shapes the user followed at each frame, and in this case, since the true password was entered, the system allows access. Now we will see a case where the user, emulating a hacker, attempts to gain access using a false password. A different password is set: open square, triangle, and pentagon. However, the user will not follow these shapes. First, the user follows the circle. Second, she follows the hexagon. Finally, she follows the bullseye. The system recognizes her input but will deny access because they do not match the password. Across multiple studies, we've found the system to be simple, accurate, and robust to calibration errors, as well as resilient to video analysis attacks. We foresee gaze gesture-based authentication as a potential solution to counter shoulder surfing attacks and a promising technology for further enhancements like deployment on smaller screens with random paths.